Hello, my name is Mr. Asprey and I'm really pleased to bring to you today the complete A-Level Pure Maths crib sheet. I've made this sheet off the EDEXCEL spec, though you could use it for other boards and just adapt it accordingly. And you can download this from my Google Drive, link is in the description. When I was at school, I would make it my priority to create a crib sheet for all of my exams, and I would get all the information which I needed and I'd put it onto as fewer pieces of paper as possible, and then I would use that as my Bible and I would have it wherever I went, and on the morning of the exam I would make sure that all of the information is committed to memory so that I felt confident going into my exam. I recommend that you do the same. I recommend you use this as a guide and you can fill it in as well. And let's get into it. Here we go. We're going to start off with algebra and indice rules. When you multiply two a's together, you would add the powers. When you divide two a's, you will subtract the powers. The bracket rule here, you multiply the powers. Negative power means 1 over, so the reciprocal. Anything to the power of 0 is 1. Anything to the power of 1 is itself. When we have a fractional power, the denominator is the root, so this will be the nth root of a. And we can also have a fractional power where the denominator is the root, and then we will use the numerator to raise a to the power of. Difference of two squares comes up all the time, you've got to spot it, and a squared minus b squared is the same as a minus b times by a plus b. Surds, when you have something multiplied together under the same square root, we can split it up as root a times by root b. And the same way, if you have something divided under the same square root, we can write that as root a over root b. This one here, I need to rationalize this denominator. So what I would do is I will multiply the top by root a and the bottom by root a. And here, if I need to rationalize this denominator, I will need to times the top by a, and I will flip the sign over, so rather than plus or minus, it will be minus or plus root b over a minus or plus root b. So that's how we rationalize denominators. The discriminant, if the discriminant b squared minus 4ac is less than 0, we have no real roots. If it is equal to 0, we have one real root. And if it's greater than 0, we have two real roots. Factor theorem, if f of a is equal to 0, then that implies that x minus a is a factor of f of x, and that works both ways. Different sets of numbers. R is the real numbers, n is the natural numbers which start at 1, 2, 3, 4, etc. Z is the set of integers, and Q is the set of rationals. Okay, graph transformations. If I add on a, that's going to be a translation upwards. And if I take away a, that's going to be a translation downwards. If I do f of x minus a inside the bracket, that's going to affect the x coordinate. And that will be a translation right by a. And if I do x plus a inside the bracket, that will be a translation left. If I do a f of x, again, that's outside the brackets, that will affect the y coordinate, and that's going to stretch in the y-axis by a scale factor of a. And if I do f of ax inside the bracket, that is going to stretch in the x-axis, which does the opposite of what you expect, so it will be a scale factor of 1 over a. Minus f of x, the minus is outside the bracket, so it's going to affect the y coordinate, which actually means it's going to reflect it in the x-axis. F of minus x inside the bracket is going to reflect in the y-axis, which will transform all of the x coordinates. Great, done with graph transformations. And over to everyone's least favourite question, domain and range. The domain is the set of all inputs, which we label as x, and the range is the set of all outputs, which we label as y. The domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. So they swap over. Okay, moving on to sequences, and the arithmetic sequence, the nth term, which are not given, is an is equal to a plus n minus 1d. The summation formula, which is given in your formula booklet, is equal to s of n over 2, two lots of the first term plus n minus 1d. Geometric, the nth term is an is equal to ar to the n minus 1. The summation formula, you are given this one, and that's why I've highlighted it in green, and that is a1 minus r to the power n all over 1 minus r. The sum to infinity is also given. It's equal to a1 minus over 1 minus r. And if a sequence is convergent, it only happens if the common ratio is less than or equal to 1, or the modulus of the common ratio is less than or equal to 1. Recursive sequences, they have a period order k if the n plus kth term is equal to the nth term. So for example, a to the 4 would equal a1. There's a gap of 3, it has a period of 3. Coordinate geometry, straight lines, the gradient m is equal to y2 minus y1 over x2 minus x1. The equation of a straight line is y is equal to mx plus c, but the alternative, and better if you ask me, formula is y minus y1 is equal to mx minus x1, which is just essentially a rearrangement of the gradient formula. Two lines are parallel if they have the same gradient. Two lines are perpendicular if their gradients are negative reciprocals of one another, so they multiply to make minus 1. The distance formula, we can use Pythagoras, and it's the change in the x coordinates plus the change in the y coordinates, each of which need to be squared first. And the midpoint is the average x-coordinate and the average y-coordinate. Circles, the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. And that's the case when AB is the centre and R is the radius. These are the four circle theorems which you need to know. The first one is not particularly common, but if you have a chord and a perpendicular bisector, that perpendicular bisector will go through the centre. And this one over here on the right, this is that if you have a triangle inside of a semicircle, it will be a right angled triangle. And this one over here is that a tangent and radius meet at 90 degrees. And the final one here looks like a party hat. That is that two tangents, if they intersect, they will have the same distance to the circle. Year 1 binomial is when we have a natural number as the power. And the formula for this is as follows. And the way I remember this is that the powers of A go down by 1 each time, as the powers of B go up by 1 each time. So b to the 0 there, b to the 1, b to the 2. And they always add to make the overall power. Year 2 binomial, again, that one is given. And what we need to remember for this is that n could be any number, so it could be fractional or it could be negative. And this works when we have 1 plus some x, but if we have a plus some x, then we need to take out a factor of a. And when we do that, we take out a factor of a to the power of the bracket. And dividing through by a will give me 1, and it will give me b over a inside the bracket like such. And this is valid for whatever the x is, so this here, modulus of that needs to be less than 1. Okay, up next, logarithm rules, and the original logarithm rule is that the base, in this case is a, when raised to the power of n, will equal x. If I add two logs together, it's the same as having log of x plus times y, and if I minus two logs together, that's the same as saying log of x over y. Log x to the k means I can bring k down to the front as the coefficient. Log a of a is equal to 1, and log a of 1 is equal to 0. E to the ln x is x, and so is ln e to the x. When I have a exponential function like this, I could take logs of it and put it as a straight line. So in this case, I would write log of y, taking logs of both sides, and then splitting up this, I will give me n log x plus log a, where log y is a variable, log x is a variable, n is the gradient, and log a is the intercept. I could do the same for this one as well. I will get log y is equal to log b x plus log a, and in this case we have log y as the variable, x as the variable, log b as the gradient, and log a as the intercept. Numerical methods. If there is a root, it means there must be a change of sign, and that is the case if f of x is continuous across that interval. The Newton-Raphson formula is given. It's the next x value along is the x value previous minus f of the x value over the derivative of the x value. Vectors. This one's really important, the fundamental one. If I want to go from a to b, it's the same as going from o to b minus o to a. The distance of a vector, or the magnitude, is equal to us squaring each of the components, adding them together, then square rooting. Two vectors are parallel if a to b is equal to some multiple of another vector c to d. They are collinear if they lie on the same straight line. And we can prove that by making sure that each of the vectors, so if we're going from a to b to c, the a to b is parallel to either b to c or from a to c. Trigonometry, sine rule, you have to remember the sine rule, you're not given this anymore. It's a over sine of a is equal to b over sine of b. And the cosine rule is a squared is equal to b squared plus c squared minus 2bc cosine capital A. A of a triangle is a half AB sine capital C. Radians, 2 pi is 360, 1 pi is 180, pi over 2 is 90, pi over 3 is 60, pi over 4 is 45, and pi over 6 is 30. 1 radian we can calculate by doing 180 divided by pi. Sectors. When measured in radians, the area of a sector is a half r squared theta, and the length of an arc is r theta. The area of a segment is given as a half r squared, open brackets, theta minus sine theta. Exact trig values. Don't need to know these as such because you can just use your calculator, but it's just good to know them. Sine of 30 is a half, and that's the same as cos of 60. Cos of 30 is root 3 over 2, and that's the same as sine of 60. Sine of 45 and cos of 45 are the same, which is 1 over root 2. Tan of 45 is 1. Tan of 60 is root 3, so tan of 30 is 1 over root 3. Oh, here we go, the cast diagram. Not many people like this, but it is really useful for finding second solutions. So, first off, if the angle is theta right here, then this angle over here is pi minus theta. This angle down here is pi plus theta, and this one over here is 2 pi minus theta. So once you have found your first solution, if you are using sine, then you would do pi minus theta to get the second solution. If you are using tan, you would do pi plus theta to get the second solution. And if you're using cos, you will do 2 pi minus theta. And this also helps us knowing which trig values are negative positive in which quadrant. So they're all positive in the 0 to 90 quadrant. Only sine is positive 90 to 180. Only tan 180 to 270, and only cos 270 back to 360. Small angle approximation, you're given these. Sine theta is theta, tan theta is theta, and cos is 1 minus theta squared over 2. Okay, reciprocal functions. You can remember these by the third letter. So the third letter for sec is C, so therefore sec is 1 over cos. The third letter for cosec is S, so that is 1 over sine. And the third letter for cot is tan, so that's 1 over, the third letter is T, so that's 1 over tan. Okay, the fundamental identity of trigonometry is that sine squared plus cos squared is equivalent to 1. Now, the other two identities, you can work them out just by dividing through. So, for example, here I could divide through by sine squared, and that will give me sine squared over sine squared is 1, cos squared over sine squared is cot squared, and 1 over sine squared is cosec squared. Or you could take it and you could divide it through by cos squared, and sine squared over cos squared is tan squared, cos squared over cos squared is 1, and 1 over cos squared is sec squared. Compound angle, you are given these. Again, it's good to know them and familiarise yourself with them. Sine A, cos B, the sine stays the same, and then cos A, sine B. For cos, we have cos A, cos B, and don't forget that the signs flip, and then sine A, sine B. And for tan, the lesser known one, we will have tan A plus or minus tan B all over 1, flip the sign over tan A, tan B. Double angle. These are not given, and these are super duper useful. You've got to know these ones. 2 sine theta cos theta. That's sine 2 theta. Cos 2 theta is very cheeky. It has lots of different uses. The first one is cos squared minus sine squared. We can rearrange this to get 2 cos squared theta minus 1. And we can also rearrange it to get 1 minus sine squared 1 minus 2 sine squared theta. So important you know those off by heart. Tan 2 theta is 2 tan theta over 1 minus tan squared theta. Right, this is a big one. R sine x plus alpha or R cos x plus alpha. Now, if you have R sine x plus or minus alpha, then what you want to do is make sure that the A coefficient goes with the sine and the B coefficient goes with the cos. And that's because you want A to be the coefficient of whatever you're transforming it into. So if I was trying to transform into R cos, I would make the A coefficient cos. I would flip the sign, but you don't need to worry about the sign if you use this method. And then B coefficient will be sine x. And as long as the A represents the same trig function coefficient as the one you're transforming into, you can just follow this formula. R is the square root of a squared plus b squared, and alpha is tan to the minus 1 of b over a. Done. Don't need to worry about the signs at all. Just make sure that you have the a coefficient representing the trig function which you're transforming into. Okay, great. Differentiation by first principles. Again, this is given in your formula booklet, but it's important that you do know how to use it. F of x plus h minus f of x all over h. The limit as h tends to 0. Gradients. Okay, so if you have a derivative less than 0, then that means that the function is decreasing on that interval. And if the gradient is greater than 0, it means it's increasing on that interval. If it's equal to 0, then that is a stationary point. Okay, the second derivative. If the second derivative is less than 0 at a particular point, or on an interval, then that means that it's concave, and at a particular point that means it will be a maximum. And if it's greater than 0, it means that it's convex, and at a particular point, a stationary point, that would make it a minimum. Now, at a stationary point, if the second derivative is equal to 0, it might suggest a point of inflection. But what we will need to do, so if and only if, we check that the second derivative changes sign either side. Must do that to prove that it is a point of inflection. That is critical. Okay, chain rule. If we have a function y is equal to a function of u, and u is equal to a function of x, then the chain rule states that dy by dx is equal to dy by du multiplied by du by dx. And of course you can always check that it's true by cancelling out, and you should get dy by dx. Product rule, if you have a u multiplied by a v, then you leave 1 alone, so leave u alone, and differentiate v. And then you leave v alone and differentiate u. Quotient rule, you're given this one, try and avoid using it if you can, but if you have to, it is v du, so it always starts with v, minus u dv, and all over v squared. Parametric differentiation, if you've got two functions, one y, one x, both of t, then the derivative will be dy by dt over dx by dt. Standard results for differentiation. Of course we know that if we differentiate a polynomial, the power comes down and then we drop the power down by 1. If we're differentiating sine of x, then we're going to get k sine differentiates to cos. And if we differentiate cos of x, k will come out, and cos of x differentiates to minus sine. The way I remember this is cos to sine, change the sign. If we're differentiating an e function, it stays the same, but the derivative of the input will come out, so it's k e to the kx. Ln of x differentiates to 1 over x, and a to the x, this is a standard result that you do need to know, is a to the x multiplied by ln a. These ones are given in your formula booklet, but again, it's a good idea just to write them down and try and memorize them if you can. Tan differentiates to sec squared. Cosec differentiates to minus cosec cot. Sec differentiates to sec tan. And cot differentiates to minus cosec squared. And of course, what you can do is if you have any of these, you could integrate them back to any of these, or well, their respective one, of course. Okay, bracket rule, my favourite. If you have a bracket and it's raised to the power n and you're trying to differentiate it, what you need to do is bring the power down, keep the bracket the same no matter what it is, drop the power down by 1 and multiply by the derivative of whatever that thing is with respect to x. This works for differentiation, it doesn't work the other way around for integration. Speaking of integration, here we are. The standard result for differentiating a polynomial, of course, is that we up the power by 1 and then we divide by the new power. E to the x differentiates itself and it integrates to itself. But we take the input and we do 1 over the derivative of the input. Like so. 1 over x differentiates to ln x. Oops, don't forget plus c. Sine of x integrates to minus cos. So we would write this. Cos of x integrates to sine. So we would write this. Now the next ones are all in your formula booklet and I would recommend not learning. They're very techy and they rarely come up, but you should know that they are there in your formula booklet if you need them. Okay, now if this is the reverse of the bracket rule, if we know what a function integrates to and its input is just ax plus b, then we can just integrate it and get the new function, and all I need to do is just divide by the derivative of ax plus b, which is a. Now the reverse chain rule states that if the denominator has a derivative which is the numerator, then I can just integrate it directly to get ln of that denominator. If I have a function raised to the power n and it's multiplied by its derivative, then I can just integrate that directly to the function n plus 1 power all over n plus 1. If I'm doing integration by substitution, the first thing I want to do is I'd want to differentiate u. And then what I would want to do is I would need to get an expression for dx, sub that in, and then what I'd want to do is I would need to convert my limits. Integration by parts, the formula is given, but what you really need to remember is late. And this is what we replace u for. And we replace u for any logarithms, that takes priority, and then any algebraic expressions like a polynomial, and then finally any trigonometric or exponential functions. If I have a fraction, the first thing I do is I check to see if the denominator differentiates to the numerator. If it's not, then in this instance what I could do is I can split up the fraction, and I could do that by x divided by x is 1, and 3 divided by x is 3 over x. Or I can use polynomial division, and in this case I would get 1 plus 2 over x minus 1 after my division. Or I could use partial fractions. If the denominator is two functions here multiplied together, and that will give me minus 1 over x plus 2 over x minus 1 when I do that. The trapezium rule is given, but it's better just to remember it in this form, which is h over 2 multiplied by the first term plus the last term plus 2 lots of all the middle terms. And the height is given as the difference between the limits all over the number of strips. Parametric integration, the formula is y multiplied by dx by dt. And sometimes integration is given like this. Don't let it fool you. This is just the integral between b and a of f of x with respect to x. And we're done. Oh, actually, no, there's one more thing, really important actually. You have to remember this for your Maths Pure A-Level exam, and that is to subscribe to my YouTube channel. And please like the video if you find it useful and share with your friends. I've got lots more content on A-Level Maths, so do check that out. And good luck in your A-Level exam. I'm sure you will do fantastically well. Bye for now.